Okay, good afternoon, everybody. As I see, most of you here, right? Today, more people. Okay, so let us see our schedule first.
Isn't it true a parent is read that you can't have just one black child? Like you either have to have two black child and no black child?
No black child. If you are red, parent is red, there is no red child. Even if you have two black child or one, two black children or one black child.
Well, I think
Right.
because I believe like one black child would violate red black tree, would it not?
No. No. If it is black, parent is black, both children can be red or black, or either one can be.
Because like the nils would make it so that like one of the black paths are longer.
Forget about nil.
Forget
That's,
about nil?
yeah, forget about nil one. Consider other stuff. So today is October 12th. So we are in the second half of this lecture, of this course. Okay. So okay. So we are on lecture on week 9. We are on second half of this course. So from now and onward, the steps, there are some steps, most of these are new to you, but these are easy and interesting. So I think without me, you can study yourself. Because there are some new steps and there are some a little bit complicated, but not as much as red black tree. Okay, and you can, these are self-explanatory, and then something interesting, you will get interest whenever you study. Then you can even study yourself. But that does not mean that I am asking you not to come in lecture. Please come in lecture, and then hopefully we will wrap up in a few weeks. And then on the announcement is that there will be a test 2 next week. So next week, when is suitable? Tuesday or Thursday? Test 2 will be next week.
So that'll be on red black trees and the data structures?
Yeah. So that will cover data structures. Data structures means it will linked list, stack QE, and then binary search trees and red black tree. Okay. So when do you want to take the test? Next Tuesday or Thursday? Thursday? Okay, so next Thursday this time. Not coming Thursday.
First?
Huh?
Well, what is the Thursday? Is that the 21st or 21st?
No, Thursday will be 21st?
Yep. Could we do it Tuesday then? Because I have another test on 21st. I have a operating systems test 2 on 21st.
Okay. So
Come on, lads, let's just get it over with.
Tuesday is just not, doesn't sound great.
do you need to do a vote?
Alright, so Thursday,
If I do a vote, then you will be loser. I don't like you to be a loser, okay? So let us do win-win situation.
Well, how about we like just put all the votes in the bucket and then you pick one and then that's it. So I have like a small.
Then today's lecture will be for voting. Only for voting. Okay. Test 2 will be comparatively easy. I will give you some multiple choice questions. Okay. And some red black tree insertion, maybe recoloring.
Are we gonna have to write pseudocode on that test?
I think no.
No.
No, no pseudocode.
Okay, that reduces my stress levels a lot.
Okay, that's good.
So it is on Thursday, sir?
Hmm?
So the exam is next Thursday?
This Thursday, not coming Thursday, not day after tomorrow.
Okay.
Okay. 9 days, 10 days from now.
Okay.
You said the 21st, right? You said next, the 21st.
Let us see.
Next week Thursday.
Next week Thursday.
Okay.
It should be 21st. Okay.
21st.
21. Okay. Not 19. Okay, so this week we will discuss hash tables and hash functions. So maybe you are familiar with some of this because some languages like Java has hash codes and then some built-in methods. And hash,
That's like that's different from like encryption hash, right?
yeah, encryption is needed. A hash method hashing is needed in encryption. So if you're familiar with some kind of encryption or a few kind of encryption, then you should be able to you should be familiar with this. Okay. So I will upload some slides okay, after this lecture. Then if you read this through even one time interestingly, then you will understand the basic things. So, in terms of English, general English, so why it is too far? So in terms of English, in general meaning, in general English, what is means hash? Hash is like make make meat or other food into hash. Okay, some kind of agreement. What this says? That's slang for. Okay, so hash in let us see images. Okay. So it's popular dollar sign, no dollars, pound sign is hash sign, right? So in our language, our country, hashing means cutting, making pieces. Okay, make some pieces. This way we have a large thing, something large or complicated. Okay, make that some hash or then some cut and some pieces. Okay, and then what is our goal? Then you will find something easier or something maybe applicable or secret or something. So if you have a large thing and then if you cut in some small pieces and rearrange, then you will get something different, right? And it may be secret to someone else. And later, to whom you are sending this, if he knows how did you cut it and how did you rearrange it, if you can rearrange, then you will get it in a regular form. Okay. So as we saw that in our previous data structures, like linked list, stack, starting from array, then linked list, stack, QE, binary search tree, AVL trees, and then red black trees. Okay, so we search a data in terms of its position, right? So in an array, we find the position by index. In linked list, tag, QE, we find the position according to, like, say, so a node has its position or next node or previous node position. Okay, but differently is hash in a hash table. We say hash table. Hash table is a table like a dictionary. Like a dictionary, that every entry has its position with key value pair. Key value pair. Okay, and then you search an item based on key value, not in location. For instance, in dictionary, if I search for dictionary in the book dictionary, if I would search the word hash, then I need to go past A, B, C, D, E, F, G, H, right? Then H, then A, then S, H. And then I get a key, a hash is a key. And then against that key, there is a description of meaning of that word hash, okay, and its uses, and some examples. Or maybe there may have multiple definitions or multiple examples, or some alternative or similar kind of definitions. Those are values actually. So the key is hash, and then against this key, whatever definitions or examples or description we find, those are values. So in a dictionary, for each word there is no index. There is no index, right? So for index, so it is not in a dictionary that we will go to 1015 index and we will find the word hash. It's not that. So hash will stay in its actual position, whatever position. It depends on the number of previous entries, right? Previous or later entries. It takes a position. The position may be changed if they add some entry more before, then this will be going down. So the goal of hash table is to goal of designing hash table to develop something, a tabular format, that is key and value pair, so that based on the value of key we can find the appropriate values. Okay. So unlike an array, that is every element has its own position with its index, right? We will not search by index, we will search by key. That is the difference in hash. So in our like whatever we say, that for instance hash function, we will say hash. A hash table is, for instance, the left side is hash table. For instance, is this table, for now let's just think about this is a table of maybe an array type table. So each array has index 0, 1, 2, 3, 4, and so on. On the right side, these are values. So if it is like a traditional array, then each element is based on, is accessed by its index. But here we are not calling this number. So here 0, 1, 2, 3, 4, 5. Actually we are not calling this index. Actually these are key values. So number 33. Okay. So a position within the sometime here 33 is a key, and sometimes this key is sometimes twisted to get its actual location. We will see that there are several processes. How do we do that? We can say you can keep it as is, Then if we keep 33 as is, then and if we put in an array, then 33 will get it in position. But for here, it's for simplicity. For instance, if you notice that this 33, maybe this is hashed with a modulus operator like module 10. So if you say 33 module 10, 33 mod 10 will be 3, right? Remainder is 3, so that it gets the position in an array or in a data table with index 3 position. So that means this 3 position is figured out calculated based on some other functions, using some other function. Okay, that is called hash function. The function maybe can be simple function, or it can be a complicated function, but it can be a combination of one or more functions. Okay, so in an average case, the complexity of retrieval complexity of an in a hash table is big O 1, that is constant time.
So to search it, you would take the
Hash
function
value.
and then get the index.
Hash value, yes, hash value will come in soon. Okay, if you example, let us, for instance, we have a data set, we have some data elements, and we want to hash them. For instance, we have some values. Let me come some actual values. Let us see. We don't have it here, but so the basis, I am coming soon. Okay, the basis of hashing is to transform the items key value into an integer value. So handling integer is easy, right? In terms of, for instance, if you have some integer values, then you can use an array. Okay, you can use an array and put that and make a link of your hash index value with the table index value. Then what will happen? Then also the advantage is that if I have some values like this, like I have some values, for instance like 33, 104, 10007, okay, maybe 208, okay, maybe 305. I have a data value like this, 1 2 3 4 5, only 5 values, for instance. And for instance, if we without any hashing, okay, if we want to put this in a table, okay, then there are multiple ways we can do. For instance, in an array, you can put 0 1 2 3 4 5, and you can put this one in 33, the next value in 104, and next value is 10007, next value 208, maybe next value 305. You can put that way, right? This is one way, like in normal array we do. Okay, so in that case, what we will do in this array, so how do we access this value, either this any value, by its index, right, by its position. But as I said in the definition, in a hash table, we are not concerned about this position. We don't consider this position. We will make its own position based on the data value. Okay, so in normal table, normal table, we access a value based on its position, right? But in a hash table, at the beginning we said that we no longer want to access value based on its position, based on its index. Maybe we will create our own index, our own position. Its value will create its own position. So instead of this, like putting like this as is, how about if we do this way? So take this one, module 10, and then we will get 3, right? First value, and take this one with modulus 10, then we will get 4. And this one, if we take modulus 10, mod 10, then we will get 7, right? And for this one, we will get mod 10, this one will get 8, and this one we will get 5. So for this one, if we take mod of 10, then for this one with 3, then this one 4, this one 7, and this one 8 and 5. Okay, then since we are taking mod, right, of 10, then we need a table. We need a table of 0 to 9. That means 10's index. 1, 2, 3, 4, 5, 6, 7, 8, and then last one 9. So you can say 8 over here, and then 9. So then what will happen, instead of using like this kind of array, so we created a new array with index 0 to 9, only 10 index. Here are mod m, because later we'll say m is 10, so we will have only 10 length, an array of length index with only 10. So then what will happen, so instead 3, so 33 will go here with index 3, and 104 will go with index position 4. So this will be 104 will go here, and 1007 will go at 7. 10007 will go here, and then at 8, then we will have 208, and then at position 5, then we will have at 5, then we will have 305. Then you see that, then at this position, how do we will access this value? With index 3. If you go to 3 index of this table, then we will get 33. Then if you go 4 index, then we will get 104. Then you get 5 index, then we will get 305, and so on. So now this part is simple, right? If we have all data value distinct, that gives distinct this index based on our function or our hashing function. But how about if I have multiple items, multiple elements that gives us same kind of index? For instance, we have one more, we have 205, we have 1305, and we have 505, and we have 705. We will see there will be multiple 5s, right, at the with index sign 5. Then what will happen? Then there are ways, multiple ways to resolve this. One of the ways is that we can make a chain over here. For instance, here 30 with 5 index, we will use another linked list here. So small linked list. So this linked list 102305, this will be linked with 205. So 205 over here, and then there will be another link. This will contain 1305. 1305. There will contain 505, and this will contain 705, and the last one index is nil or null, right? And then there is a small linked list over here. This will be linked. So compared to the array elements, this linked list is comparatively short linked list. So in order to access, for instance, 705, we need to come to with index 5, and then it will see, hey, it has another linked list. Okay, it has a series of numbers. So then you jump to the linked list and you check one by one until you find it. And if you even go all the way to the linked list, if it does not exist, then it does not exist. Okay, this is one way to do that.
Does the linked list have any particular order?
Yeah, it will come the order, the first one, the first number, it will come first
So
order,
like
second.
First come, first serve?
Yeah, this will come.
So you just traverse through the list until you
Yeah,
find
until
it.
you find this. Okay, and there are other ways. For instance, there are multiple another alternative ways. For instance, if you saw that there are some blank, right? Some blank and some spaces, right? Unused spaces. So what we can do, we can, instead of, if we don't like to use linked list, then we can do another way, so that we can go to the find the next empty unused space and put whatever it finds in next unused space, put it there. For instance, in that case, whenever you come to say like 205, then it will say, hey, I'm 305, I'm not 205. Go to the next link. Here is the link. You go there, you will see 205. Right? So that is another way. So in that case, for instance, there will be two hop, right? One from here, another one here. So still it will take constant time. It's considered it will take time. You have a question? You have a question?
Bucket sort a kind of hash table then?
Sorry?
Is bucket sort a kind of hash table?
Yeah, in bucket sort we do some kind of hash table, hashing. Yeah.
So when multiple have the same hash value, that would be called like collision?
Yeah, collision. We will see how to resolve collision.
So linked
That is called
list
collision,
or
yes.
Going to the next empty
Yeah.
space would solve collision.
Collision, yes. So there are some ways how to resolve it, but these ways are interesting. If this is self-explanatory, even if you read one time, you will understand at this time. Okay, so we will see some techniques how to do this. So does anyone has any questions so far? So as we saw that bucket sort, yeah, the good catch. Bucket sort already use hash by 10, for instance. Okay, hash with 10, and then based on this last value, okay, it put in a bucket, in an appropriate bucket. So everybody is good until so far. This is nothing complicated, okay, but maybe there is some little bit complexity, but not that much. So we will see, our challenge will be finding to good hash function. If your hash function is good enough, then it will be faster and easier. Okay, sometimes it is a challenge to find an appropriate hash function. But once you find an appropriate hash function, then you will see that it is easy and interesting. So a good hash function should be relatively simple and efficient to compute. What do we compute using hash function? You put keys in the hash function and we find an appropriate value. Okay, so we compute values corresponding to a key. So so like 40-50 years ago, when people use dictionary, paper-based dictionary, right? The dictionary had like some words, the keys and description, the values, and for rare cases it would have maybe some pictures. Okay, now if we have digital dictionary, you see that word is meaning, different meaning, its uses, its sentences, paragraphs, alternative meanings, and sometimes there may be some images. Click on the link, you will find some image. You must find some video, audio, and text, a lot of things, right? So you will see, so those are actually implemented. See what I wanted to tell that. So dictionary, I'm telling that dictionary in old school fashion, like 100 years ago, the book copies of dictionary, and now dictionary, digital dictionary, are far different, right? So our digital dictionary are have a lot of information compared to our text or text-based dictionaries. So for instance, now think about that. For instance, we are developing a text-based dictionary, not digital dictionary. So there are many ways. For instance, how do we do a dictionary in a dictionary, words or words? So we know that words are character values. For instance, there are 26 character letters in alphabet, standard in English alphabet. So so if we take a table with index 27, 0 to 27, that means 0 to 26, 23rd, then even we can arrange all words in the world in that dictionary letter, right? A, B, C, D, E, F, G, H. We can say A for with index 0, B index 1, C index 3, and then we can put this. And then whenever we have multiple words, we will saw that we will use another linked list over there, one after another, or we can see other scopes when we do. But in a linked list, in a traditional library, whatever we saw, this is implemented what we saw like this way. All letters start with A, goes in A position. It does not overpass after B or C. But in a digital dictionary, it may happen. Wherever we get space, put in that space in memory, and put a link over there. So there are many ways. For instance, we are not, for instance, if it is a normal dictionary, paper-based dictionary, right? This word, term, where it will go? It will be after ST, right? A, B, C, D, E, F, G, right? S, and then after S, then you will see T. But in digital dictionary, it does not necessarily to go there after T, ST. Maybe if there is an index, paper-based like index, that will see after S and T, you will see that. But in computer memory location, what it will take? Okay, there are multiple ways. We know that, for instance, say there are ways that, for instance, if you say one occurrence is that if we convert each of these individual character in ASCII code. ASCII code is available and implemented in operating system. All operating systems and all programming languages understand ASCII code, right? Whenever a character is entered, it converts into ASCII code, corresponding ASCII code. So for instance, if for the simple implementation, one hash table could be, for instance, convert T in this ASCII code. T is 84, maybe position 84, right? Uppercase T in ASCII code. And then put O is in maybe 111 in ASCII table, and M is 109. Okay, and let us see that ASCII chart. Let's see, ASCII table. T is 84. T is 84. Lowercase o is in 111, and lowercase m is 109. Okay, so 84, 111 and 109. So what they put this 84, 111 and 109, and they made a quadratic equations. For instance this is index 0. They made something different. If for simplicity you could do 84 plus 101 plus 109, whatever you get that hash code. Or they made something different. For instance, they put 27 with index to the power 0, then 27 to the power 1, and then 20. So for this way, for all three letters, there will be different hash value, hopefully, different hash code. And then now, if you got this hash code, for instance this one, you can use it as is, or you can use it with another module operation. Then if you do another module with 10, the index will be 2, right? Easy to calculate with index 10. And then for instance whatever you follow, either module 100 or module 10, and then you got this position and you put that key, this is our key, and on that hash code, according to that hash code or hash value. Okay, so for instance, and that way, the simple way that they use this way, and if you calculate this way, all of this number like Tom, Dick, Harry, Sam, Pete, then you will get all different hash code values. Now with these hash code values that I said, that whatever you want to do, you can keep it as is, or you can do module operation, okay, or you can get something else. For instance, someone wants to say, okay, I will take only the last 2 digits. I will take only last 2 digits. And then, yeah, actually, how do you get the last 2 digits? In calculation, if we module by 100, right? Then we get the last 2 digits. So whatever you've said, for instance, this is our key, and this is the value. So now a key is going to be accessed based on this value. Okay, and it's up to you how these values will be put in computer memory or in a table. Usually we put in a table with index. So here there are many ways. So for instance, in this slide, here it is taken with modulo 5. I don't know why they took modulo 5, because there are only 5 elements. There are only 5 elements, so it's easy. So take modulo 5 elements. Then we need another table with only 5 size with 5, right? And that in case luckily, so when do modulo 5, they got luckily all these index distinct, right? Oh no, there is one duplicate, but most of them are distinct. So now if we make, for instance this one, so then you see that for this one, for Tom, then it will hash code with this, and then is hash code will be ultimately given 2, and that is the index that is associated to the index where this will be put. So then it got Tom's will get position 2 based on this hash code, and then Harry will get 3, and then Dick will get at position 4. You will see that Dick will get at position 4, and then Harry will at 3, and let us see, Sam is going to 0, and then again Pete is going to be 2. So then 2 is already occupied, right? So if you want to Pete over here, then Tom will be deleted. one memory location can hold only one value at a time. So term will be overwritten. So then this is called a collision. This situation, okay, called a collision. So here what we can do, so we know that there are only 5 elements. There will be only 5 elements in my dictionary, 5 words in my dictionary, and I have 5 pages allocated, okay. And at this position, if Tom and Peter are fighting to stay on same page, but since Tom came here first, right, so let us give the first priority to Tom here, and let us find an alternative way for Pete so that he can find an empty space. And definitely we know that there is an empty space for Pete, since we have there are only 5 elements and we took hash 5, okay. So we are expecting that for each key, these are keys, okay, there will be a distinct value or hash code, but it's not a problem if we do not find one or all distinct. Even if we find some duplicate, then what we'll see that we know that there is one empty space. Then now we need to find a technique. What is the technique? To look for the next available space for Pete to stay in. That is kind of a little bit kind of challenge, okay. And in this situation is called collusion, okay. Said that. This situation is called collusion, and there are some ways to resolve this collusion, okay. So there are a few methods, older methods for resolving collusion. One is called linear hashing, another is called double hashing, another is called quadratic hashing. Quadratic hashing means make a quadratic function, use a quadratic function. Quadratic function, for instance, we saw a few minutes ago, if we use this kind of function, okay, so then hopefully there will be a different hash code, a distinct hash code, but it is not guaranteed and it is not needed to have this, okay. There are other ways. For instance, sometimes if it is easy, it may be resolved using linear hashing, sometimes double hashing, sometimes quadratic hashing, okay. So we need to understand this, at least these 3 kinds of hashing. There are other kinds of hashing also, and there are a lot of research still going on to find new hash methods or hash functions. So what is the goal of this, using this method? To find the next available empty cell. For whom? For the key that initial expected position is occupied, right? For instance, here Pete are supposed to get position 2, but that position is occupied by Tom earlier. So Pete cannot take this position. If that happens, then Tom's value will be overridden. So we need to find a position for Pete. Maybe that position, if we think that this is an array, circular array, whatever array is it, so we can go index from, if we go last index, then we come back to the first index again. And one thing is that definitely we know that for this case there are only 5 entries, 5 keys, and for 5 keys, so the hash method we used modulo 5, right? That means the remainder will be 0 to 4. That means 5. So we expected that there would be 5 distinct hash codes, but this did not come in. There is a collision. Okay, but later we found that there is a way that how to find this one. So the simple way could be go to the next, next, and ultimately sometime you will find an empty position. Then the question is how should we go? How much next we should go? So as we know that here is hash value is 5, right? If we call this M, so definitely we need to go the next 4 position, and hopefully within the next 4 position you will get an empty space. So it's not here, you can go 1 position down, 1, it's not available here, go another position, 2, it is not available here, go another position, 3, and it's not available here, it is go 4, and then you got empty. So how far we will need to go? Just less than 5. So when we doing another searching for less than 5, it is not too much, it will not take that much time. So this is why it is called the time complexity is constant. Okay. So now we are saying that we want to see that hash function different, at least these 3 kinds of hash function. Okay, one is linear hashing, and there is double hashing, and third one is quadratic hashing. You have a question? Okay, that's good. Does anyone has any question so far? Okay, again, before we go to that hash functions, what do we need to do? What is our goal? To find an appropriate position for fit for this key value that was supposed to get position but did not get that position because of the collision. Okay, now we will see that our goal is to find the position for fit with less effort, with less complexity. Okay. So the goal of the hash functions are to map keys to within smaller range. The range will be 0 to m minus 1. Whatever m over here, what is m here? So m here, this is modulo, this is the m, it's 5. So we will go map keys to smaller range 0 to m minus 1. Okay, and this mapping is called hash function. This is the hash functions. Why do we use hash function? To map the keys for getting unused position. Okay. So this is like in the book, maybe you will see that this kind of hash functions. So for instance, the set U is a universe of keys, set of keys. Okay, universal set that contains all possible keys. Okay, and this is T is our hash table. Okay, this is index with 0 to m minus 1. You see that this table does not necessarily need to be very large. Okay, and this table size is not required to be the size of keys, these distinct keys. If it is a regular or traditional array, then we would take this table as size length of these keys. How many distinct keys are there? Okay. But what we are doing over here, this table is concisely smaller, right? So its length, table length is 0 to m minus 1. For instance, traditionally it's mathematically easy to get index. M is 10. Find modulo with 10, easy, right? In a second we can find the position. Okay. So here it says that whenever a record to be inserted maps to an already, what does this says? As an key inserted. Okay, the thing that we discussed, whenever a entry is going to be inserted in a key, if that is already occupied, so then this situation will happen, collision will happen. And then our goal is to find the next empty position for 5, element 5. So this is, the other elements is not easy to see over here. Okay. The simple way of solving a collision is resolving by chaining. How do we do the chaining? Using a linked list. For instance, here, this is visible. So you see the 3 keys, K5, K7 and K2, right? Both of these, they indicate this position. They get same hash code. Okay, so that's one of the way is to use a linked list at this position and going one by one. So K5 it comes first, then it goes here, then it links, it gets another link, so the next node gets K2 and then next node gets K7, and for instance like this. For instance, wherever for all the positions or the key value position, if there are duplicates, then use a linked list at that position. And it is expected that based on the number compared to the number of keys, okay, the values, there will be only a few duplicate values. Not all values will be same. So for only a few duplicate values, there will be only a few and smaller linked list. And this linked list size will never pass the length of this T table, right? What is the length of this T table? M, right? 0 to m minus 1, right? Is index with 0 to m minus 1. So then this linked list will also be less than m. Let's compare that. So sometimes it can be a singly linked list or it can be doubly linked list. What is the hash value? Maybe 4, right? Chapter. Okay. For instance, for any value I, if it is happened that there are multiple values, multiple keys, 49, 86 and 52, they are giving same hash values. So then at this position there will be this kind of linked list. So in the worst case, very worst case, that may happen that all numbers can have only one in one slot. that is the worst case. In that worst case, so it will create a linked list. So we know that in a linked list, for the worst case, that the time complexity search is theta n, right? So in that case, it will be for the worst case theta n. But in average case, we saw that theta 1 for hash table or access time. Okay, now let us see some examples. For instance, here, and this says, for instance, how to make chaining. So I don't need this. Let me see what do we need over here. Okay, I need this one. How to choose a good hash function. Okay. So as we said that a good hash function should distribute the keys uniformly into the slot of the tables. Okay, and it would be nice and better and best if our hash function is good. It depends on the hash function. How is hash function is written? If hash function is used, if hash function is used good, then it will be a good table and then it will be more efficient. Now we saw that there are few ways that how do we find hash function. The easiest way is to use module operation. Since in hashing hash tables we are finding numbers, integer numbers, hopefully all positive numbers. Even we take ASCII chart, ASCII table, or then we are getting all positive numbers, right? And so the easiest way to get modulus. So modulus gives us the remainder, right? If we divide a number k, okay, by m, then what is the remainder? Both integer numbers. This is called division method, modular division method. Okay. So the formula is m will be table size, right? M will be table size. Length of the table, which table size? Hash table size. So now, and it depends on how do you get the key values. Sometimes you may get the key values as numeric values. Sometimes you may not get numeric values. You may get ASCII values, character values. Then if you get character or string values, convert that as a key value, as a integer values, and then use this kind of modular operation. I will take that and go. So we have 5 points for class attendance, right?
Yeah,
And then percent class activity. I gave you 8 points, so if you do not focus on class, I'll give you. Let's give addition over here. Let's take that one before I forget.